Hello YouTube. So today we are going to perform a static simulation on this table. So let's begin. Take a new file of part, change the unit to mmgs. Here take top plane, go to center rectangle and draw a center rectangle. No need to give the dimensions. Okay, draw it approximate. Then extrude it like this much. Okay, then go to fillet, choose this face. Suppose 1 mm is the fillet. Choose the entire face. Click on OK. Okay, now select the bottom part. Click on sketch. Here again choose center rectangle. Suppose this is a rectangle, bring it somewhere in middle like this. Okay. Now draw two lines in between and make both of the line for construction mode. Then select this square, go to mirror entities, select this line, mirror. Then select both of the upper squares, again go to mirror entities, select the bottom line, mirror about the bottom line and mirror. Then go to features extrude. Now here extrude like this much. Okay, it's enough. Okay, so we extruded this much. The geometries are merged. Now select this face, click on sketch. Here suppose if we select 2 point rectangle, select this much, go to features extrude and here select up to next, click on OK. So see, now go to select the feature, last feature, mirror, and here select or not front plane, delete, select the right plane and tick OK. Okay, so this is made. Now select this face, click on sketch. Here again select center rectangle and draw rectangle till here. Again choose a center rectangle and draw rectangle till here. Then click on features, extrude and extrude it up to suppose 20 mm. Click on OK. This geometry is created now properly. Okay, so the table is almost created. Now only the last part is remaining. So suppose select this face, click on sketch. Now here select 2 point rectangle and draw an approximate rectangle like this. Go to features, extrude, select here up to next, click OK. Okay. Again select this face, click on sketch. Again select a 2 point rectangle and here select this much. Go to features, extrude, up to next, click on OK. Now select the last feature, go to mirror and here select the now not right plane, select the front plane, click OK. Ultimately now the entire geometry, entire table is completed. Now go to the isometric view. Okay, so the next step is to add in the simulation. So go to Solidworks, add in, click on simulation. Now it will take 5 seconds for the simulation tab to appear. When the simulation tab appear, click on the simulation tab, go to new study, here choose static, click on OK. Okay, so now the first step is to apply material. So go to apply material. Here we'll have to apply wood. So see here, down here there is wood. Okay, there are all other types of materials also there. So if you can apply plastic or any non-material if you want, non-metal, but we'll take wood. Suppose this wood, now we'll have to take the first wood. Okay, click on apply, close. So see the material is applied. So this is our table. Now the next step, there are no connections. Connections are applied only when there are multiple geometries. So this entire geometry is a single geometry, so there is no need of connections. Go to fixture, right click, select fixed geometry. Fixed geometry is when which is the faces which are going to be fixed with grounds, okay, or which are not going to move over any degree of freedom, like XYZ axis or roll around any of the axis. So those have to be fixed. Okay, so the fixed faces are going to be the bottom faces of these legs. Okay, okay, so this okay, so these four faces are going to be fixed. Click on OK. Okay, fixed support is indicated by the green arrow. Then the next thing is external load. Go to force. Now here, change the unit from Newton to metric, which is kilo force. So suppose now here the value that I want to keep is 80. Suppose any thing of 80 kilo is kept on the top face. What will be the stresses that will be generated inside the wood? The forces is denoted by the pink or purple arrow. Okay, and we have selected the entire face. This means that the force is uniformly distributed over the entire face. Now the next second last step is to create a mesh. Okay, now you can select fine mesh if you want proper results, but then it will take more time. So I'm going to select middle only. Right. Okay, so the mesh will be generated now. So see, this is the mesh that is generated. If we would have selected fine mesh, then these triangular elements would have been of the smaller size. Okay, see, proper mesh has been generated. Now the final step is to run the study. Okay, the time it takes for the study to run depends on the specification of your PC. Now here go to isometric view. So see, this is the isometric view. So just for 80 kilograms, is there going to be this kind of deformation? No, because for the better visualization, the SolidWorks has scaled the result. How much it has scaled the result? It has scaled the result out 71 times, which means if there is a deformation of 1 mm, it is showing the deformation of 71 mm. Okay, why? For the better visualization. Now, if you want to see it in the scale of 1:1, just uncheck the deformed result. So see, there is going to be no whatsoever deformation of the geometry. If you want to see what is the deformation, just click on displacement. Okay, here also uncheck the deformed result. And here go to chart option. Here change this from scientific to floating. Click OK. So see, the maximum deformation that is going to take place in this middle area, which is shown by red, and that deformation is going to be 0.2 mm. 0.2 mm, that is 20% of 1 mm. Okay, so this is very less deformation. So the wood structure is quite strong. Okay, it can easily handle uh, like 80 kilograms of weight. Okay, and what was the initial extrude that we gave to this? That was 10 mm. So 10 mm, that is 1 centimeter of wood of this material, which is balsa wood. Okay, it can handle 80 kilograms of weight. Now, suppose if you want to see what is the factor of safety, just right click and here go to define factor of safety. Click on OK. So the factor of safety is found to be 3.2. So if you go to stresses, now click here, go to chart option, change this to floating. See, count these numbers. So it is a 1, 2, 3, 4, 5, 6, 7 digit number starting with a 6. Okay, and the maximum that is the stresses are going to be also a 1, 2, 3, 4, 5, 6, 7 and 8 digit number. Okay, so that is why the factor of safety is found to be 3.2. The minimum factor of safety that we need is it is 1 to 1.5. Okay, now suppose if I change the condition, like suppose if I edit the properties over here, if I take it to 160, click OK and rerun the result. And now if I go to the factor of safety, it is found to be 1.6. That is the exact half of what we found in the previous result. Okay, because we doubled the force. Okay, which was 60 kg, we doubled it to 160 kg. Okay, more than double, like 60, so we take 160 na. So we added 100. So it was before 3.2, now it is 1.6. It was 80 kg before, so we make it 160. Okay, so we doubled it. Now what we'll do is this stresses. Okay, let's see what is the displacement in this case. Before it was 0.2, now it is 0.5 mm. So these stresses that are developed on the entire face, right? So the forces are equally divided over the entire face. Now, if the forces are going to be, suppose if I'm keeping a square block, okay, then what will be the results? So let's see those results. So how we'll do that? Just go into the model, select this face, click on sketch. Here, choose a rectangle, 2-point rectangle. Okay, suppose the block which we are going to place is of this much dimension. Here go to curve, go to split line, select this face, click on OK. So see, this face we have created now. Okay. Now if you go to the static study, now just delete this force. Again go to external load force and select only this face. Okay, so only this face is selected now. Now onto this face, again choose your metric and change the unit to suppose. Okay, so suppose 5.3. So now we are applying a weight of 5,000 kilogram. Now let's see what are the results. Okay, it was created the mesh, it updated the mesh. We're solving the result. Okay. Click on deformed result. And now here if you see, so this is the excessive condition. The displacement that they are saying is going to be 37 mm. So 37 mm displacement will not be able to handle. Okay, so it will break. And the factor of safety is going to be 0.03. So this kind of weight, this table cannot handle. Okay, now if you see here, if you see, check onto the deformed result, the displacement they are saying is 37 mm. And now they reduced the scale. Before they were taking a scale of 70. Now the scale they are taking is 0.5. That is the results which they are showing here from the top lane to here till the bottom is 0.5, that is 37 divided by 2. Okay, which is about 17 or 18 mm from here. So that is the scale they are showing. Now if you want to see it in the proper format, like where the maximum stresses are going to be generated, so you will see, you'll just go to right click and here you will go to ISO clipping. Okay, now here if you want to see the maximum displacement, so you just want to see the yellow part. So yellow part means that is 28. Okay, so here change the value to 28, click on OK. So see, the maximum displacement is going to be generated on this part only. So this way you can visualize, or you can input this in your PPT also. So that is all about the static study. Now we'll just take the last part, that is animation. So right click, go to animate. By default they are showing it in 5 fps. Now if suppose we change the frames to 40, here again click on play, so it will recalculate all the frames. Okay, all the 40 frames it will recalculate. And suppose if you increase the speed, so see, this is the animation. Okay, so this is all about the static study on a table. And now that's all for today, so stay tuned for the upcoming videos also.